Welcome you all for the third webinar on how to be a good researcher, organized by IEEE Power and Energy Society Sri Lanka's chapter in collaboration with IEEE Young Professionals Sri Lanka and IEEE Women in Engineering Affinity Group of Sri Lanka as a part of IEEE PES Day 2020. Our guest speaker today, Professor Janaka Ekanayake, will deliver a remarkable session, and thank you very much, sir, for agreeing on this. Professor Janaka Ekanayake is a fellow of IEEE, IET, and IESL Sri Lanka. Professor Ekanayake is the Chair Professor of Electrical and Electronic Engineering, University of Peradeniya. He is also a visiting professor at Cardiff University, UK, and University Tenaga Nasional, Malaysia. He has published more than 75 papers in referred journals and also co-authored 6 books. Professor Ekanayake is recognized as the most outstanding senior researcher in the field of engineering through CVCD Excellence Award in 2018. He is an expert on renewable energy, their connections, and modern power systems. Also, he has received many presidential awards for scientific research. I cordially invite you, sir, to carry on the session. Before that, for the participants, I would like to give a head up on the Q&A session. We have shared the link with you in the emails as well. So in the chat also, you will get the link for the Q&A session. Please submit your question to that link for the Q&A session after the webinar. Over to you, sir.
Thank you, Akila. Good afternoon, everybody. I think after listening to 2 technical sessions, I'm going to talk about more general things. But having said that, in my presentation also, I have included many technical know-how. So the presentation today is how to be a good researcher. And as Akila told you, I'm attached to the University of Peradeniya. Sorry. This is the outline of my presentation. I will give you 1 or 2 slides just to show my credential to talk about this topic. Of course, Akila has already given you more of that. And then I will take you through many tips to be a good researcher. Also, I would like to dedicate this presentation to late Professor W.P. Jayasekara, who taught me the basics of research when I did my undergraduate project with him a long time ago. Let me first take you through my journey. I started my engineering career in 1983 as an undergraduate at University of Peradeniya. And after a long spell of time, maybe longer than most of you, we graduated in 1990, and after that I joined university as a lecturer, probationary, immediately after I graduated. Then 1992, I went to University of Manchester Institute of Science and Technology to read for my PhD, and returned to Sri Lanka in 1995. And then I was promoted to a senior lecturer, and in 2003, I was promoted as a merit professor in the same department. But 2007, I decided to quit my job, and I went to the UK and joined Cardiff University as a reader, and I was there nearly for 6 years. In fact, I was the only one who left UK 1 day after getting permanent residency. Then I joined Peradeniya as the Chair Professor of Electrical and Electronic Engineering in 2013, and right now I'm with the University of Peradeniya. 3 professional milestones I achieved afterwards were the Fellow of IET, Fellow of IESL, and Fellow of IEEE. And of course, Akila has already told you about some awards that I received mainly for research that I have been carrying out. Now, so let me take you through some tips to be a good researcher. The first important tip is you should be systematic. I know that people use a lot of ad hoc approaches to do research. So I'm going to take you through a systematic way of doing research using a simple example. Example I'm going to use is the offshore hub in the UK. We call it Dogger Bank. Dogger Bank will be the largest offshore wind farm in the UK. When it is completed, it will be 13 gigawatt altogether. Remember, our maximum demand is around 3 gigawatt. So this is like 4 times our maximum demand. Now, it's already started through two partnership between SSC, which is this Scottish Southern Electric, and Equinor is a German company. So there will be two things we need to do in this particular wind farm. One is to aggregate the power coming from different wind farms. Remember that even though we call it Dogger Bank will have many sections called A, B, C, D, and so on. And the power coming from those wind parks should be connected, or the wind farm should be connected and bring it to the mainland UK. And there are also interconnections planned to Norway and Netherlands, but they are not yet materialized. Okay, let's look at the aggregation, not the interconnection. Now, as you can see, these wind farms are very, very big. The areas allocated for each wind farm is more than 500 kilometers squared. And the distance from the UK seashore is to the nearest point is around 131 kilometers. So it's deep in sea. You will find Dogger Bank. Now, basically, what you are seeing here is let me use small. Yeah, this is one of the wind farms. I'm going to call it wind farm A, and wind farm A, B, and C need to be connected together. So you can see that there is a AC connection, and everything comes into that bus bar. So your wind farm A, the power coming from wind farm A. I'm only showing you, the two small parts of that wind farm, but it may have more than 2 modules. Then the power from wind farm B comes to the same bus bar, and power from wind farm C comes to the same bus bar. Then you use a AC-DC converter and convert it to DC and send it to the mainland through a DC link. Now, this one is called an AC hub because the connection is through the AC bus bar. If you look at the one on the right, you can see that the wind farm A is first connected to the AC-DC converter, and at that point, the wind farm B and C are connected. So it's a DC hub. Basically, you have a DC bus bar. Now, the AC hub is favored against the DC hub. Main reason is still there are no commercially available DC circuit breakers, even though there are few competitors working on it. They are still not on the mainstream. So I'm going to use this AC hub to take you through the research process. So research always starts with an idea. Now the idea was the AC hub that I was showing. And that idea need to be converted into what we call the research questions or problems. And then you start reviewing the literature, related literature. Now, remember, these days there are so many journals available. Also, in some of those journals, you have to pay and you can publish. In some, they are very competitive to publish. So you look for good journals and read relevant papers. And once you finish your literature review, remember the literature review will never finish. It will be, it will start from this point and you need to carry on it until you finish your writing up or finish your paper, whatever it is. So once you are doing the literature review, you can refine your idea and the research problems and so on, and then move on to the next step, which is the plan and design the research. Here you will select different methods and tools required to carry out your research. Of course, you can use the knowledge that you gain from the literature review, as I said, it's ongoing, to refine your methods. Then you generate results, and finally you interpret results and draw conclusion. This is the typical research process. So, okay, so let's take this AC hub that I was showing you as my research idea. Now the research, the problems which came one's mind is what should be the frequency of the AC hub? That is the main research question. Of course, you will then need to think about some sub-questions. Should that be 50 hertz or 100 hertz, or can't we have higher? Because remember, this is an isolated grid connected to the mainland through AC to DC converter through a DC link. So you can have any frequency you want, but what should be that? So another sub question we can ask is, what are the problems associated with operating the hub at non-standard frequencies? So that's your research question. Then, of course, from the literature review, you can work out what are the frequency dependency of different components used in these wind farms and altogether in the wind park. If you look at cables, IEC 60287 defines the ampacity or the current carrying capacity of a cable, and you can see clearly which has a frequency component here. So frequency component there. So it is frequency dependent. Then the length that your cable can have, the critical length, depending on the reactive power generation generated by the cable. Again, there is a frequency term. And the maximum cable length, again, there is a frequency term. Then if you look at the transformer colos has a frequency term. I will show you another more complicated equation for the transformer core, and for the reactive power compensation that is essential for DC link, you need to, there is a frequency term. So all these are frequency dependent. But if you look at the wind generators, now in good old days, in 90s, the wind generators were fixed speed induction generators, and they were heavily depending on the frequency. Then in early 2000, we introduced what we call the doubly fed induction generator, and they're still in use in some part of Scotland, in Denmark. They are heavily used. Then, of course, more recently, the full power converter geared turbines appeared. Basically, what you do is you convert the wind power into DC and invert back to 50 hertz or whatever the frequency you want. So you can see that there is a clear decoupling between the wind turbine side and the grid side. So you can have any frequency for your grid. There's no dependence on the grid. The more recent wind turbines are the permanent magnet type, which are having like 100 pole or 120 pole machines, but again with full power converter, but gearless. They are directly connected to electronics. And more recently, the American company introduced high temperature superconducting wind generator, wind turbine, but of course it's not yet come into the mainstream. So the Dogger Bank will most probably use the permanent magnet full power converter ones. There is a Vestas machine right now. Each machine is 8 megawatt. So most probably that will be the one which is used at the Vestas. So the wind generators are frequency independent. So we can have any frequency on our aggregation grid without any restriction. So then the next step is plan and design our research. Now, in this particular case, of course, you can start, you need to do a techno-economic study. So you can start with economic study, analyzing how the size and the corresponding cost associated with the frequency. Then, of course, you can simulate your network in some simulation platforms such as PSCAD or Plex or somewhere, and see whether your controllers and everything is working perfectly under the frequency range that you determine from the economic analysis. So this is a simple economic analysis that we did for a study. Basically, you develop, determine the maximum AC hub cable length. That means depending on the distance from wind farm A to wind farm B or to C, you can work out the maximum AC hub cable length. That will give us, if you look at the equation 3, sorry, I'm going back. That is this equation, the maximum length, equation 3, you can see that is frequency dependent. So if you know the maximum length, you can work out the frequency range you should work on. And once you know the frequency range, you can then move on and calculate the amplicity. From that, you obtain the number of cables required. From that, you obtain the cost of cables, and then design the transformer and obtain the cost of the rest. So basically, this is the procedure, systematic procedure that we use to obtain the cost of the various constitution component required for the wind farm. And here is the cable length. You can see that if your wind farm is operating at power factor of 0.99, you at 100 hertz, the maximum length you can achieve is 10 kilometers. But at power factor of 0.85, you can go up to 40 kilometers. So depending on the length, you can decide what frequency range is available. Here we are considering 220 kV, 1000 millimeter square cables. And from once you work out the frequency range, you can work out the cable amplicity. Again, you can see for different cables, 220 kV, 1600 millimeter square, 1000 millimeter square, 800 millimeter square, 132 kV, 1000 and 132 kV, 800, how the amplicity or the current carrying capacity of the cables vary with the frequency. Once you know that, of course, you can work out the number of cables required under different frequencies. And from that, you also can work out the transformer. This is the colos of the transformer and the enclosure and so on. And you can then work out the total cost of cables, transformer, and compensation equipment. And while you can see that the total cost, this is in million euros, reducing up to 60 hertz and then start increasing. Then of course you need to also consider the offshore substation platform, the capital cost for that. Remember, the higher the frequency, your substation platform becomes smaller. So the logistics to accommodate that becomes less, so the cost comes down. So when you add those two, this is the final cost function you get. You can see that somewhere around 80-90 hertz, you have the cost. So that way you can work out the cost for the offshore hub. Now, that's just to illustrate how you can systematically work out answer the research question. Then you can interpret your results and draw the conclusions. Now, as I said, if you can go for higher frequencies, there is a substantial reduction in size of major electrical components, the platform, cables, and so on. However, the power transfer capacity of the cables reduces with the frequency. And remember, in the simple calculations I showed, I only used the first order calculations, but there are second order effects which also need to be incorporated into your equations. So that's basically the process. So as just to remind you, you start with the idea, then the research problem and question. From there, you do the literature review and refine your problems. Then you develop your methods, and then you take your results and then interpret your results and draw the conclusions. The next tip to be a good researcher is you need to be timely. If I know that some people are doing appropriate research, but they are ancient, so you cannot really publish the research. You will not get grants for that research. So you need to think about timely research. For example, if you can think of anything that can relate to COVID-19 today, that will be timely research, and I'm sure there will be many parties who are willing to support. For example, the best way is if you can relate your existing research to the current situation, that will give you some advantage over the time. Now, one thing I was working on was some DC network for transport sector, but then, with the COVID-19, there was a real issue of the transport energy security. Remember, our transport sector is dependent 100% of imported fossil fuel. And during the corona crisis, pandemic, we didn't generate any foreign currency. Of course, the transport also a little less, but immediately after the curfew lift, people wanted to start and then, of course, there may be difficulty of bringing the fossil fuel to the country. So one possible solution is to promote electric vehicle and charge them with indigenous energy sources such as solar, photovoltaic. If you can do that, we can develop a transport system which is independent of the foreign imports. Now, if you look at a charge station, right now we don't have large charge stations, but what you are seeing here is what you would see in a present system, where you connect your solar power, using an inverter connected to the AC system, and then connect your electric vehicles through a AC to DC charger. So you can see that there are a lot of unnecessary conversions. You had a DC source. You start with a DC source, which is your solar power. Your car is DC, but you do have many conversion stages before before sending power from the PV to car. So one easy option would be to use, or the more efficient option would be to use a DC microgrid. Here you can see that the solar power is directly connected to a DC bus bar, and your car charger can then directly connected to that bus bar. Or if depending on the size of the charger, you may need a DC-DC converter. But remember, DC-DC converters are much more efficient than inverters or rectifiers. So we developed a DC microgrid. In fact, we built one a while ago. We didn't think about transport security at that time, but we developed all the components, and we think that we can do some timely research for enhancing the transport security using this system. Then, of course, to be a good researcher, you should publish regularly. Now, remember, there are few ways you can publish. You can publish a review paper. You need to review about 100 papers and write a summary paper which gives which extract the essence of all the papers that you have went through. Now, I must say that even though it's you may think that it's easy, writing a review paper is the hardest one. Then, of course, you can publish your simulations with some literature review in a conference. But if you can back your simulations and the knowledge with some theoretical background, then you can go for a journal paper. Usually, if you have good practical work, you can hit one of those high quality journals. The journals are rated based on what we call the impact factor, and also there are Q ratings, Q1, Q2, Q3, and Q4. And the Q1 papers are having high impact factor and considered as the best papers. And if you can publish on one of those, your research really recognizable. And of course, as I said, it is easy to publish if you look for a new area. Remember the old areas, many people has published, so it's hard to publish on areas which everybody is working on. But if you can relate it to the new current situations like COVID-19 pandemic, then of course the publishing becomes easier. So if you publish top-rated papers in top-rated journals, usually you get recognition, grants, and students. Normally that is the case. So this cartoon shows you your research cycle. You read many papers as possible, then you write, then you rinse, and again you repeat the process. So this is the typical research cycle. But only by writing papers you can master the art of scientific publication. Remember, it's very hard to write a good paper. You need to spend a lot of time, but once with the experience, of course, you will start writing good papers. Now, when you are writing a paper, the first thing you need to work out is there any novelty in what you have done? How you do that? You need to do a good research literature review and see whether your work contribute to advance the state of art in your field and how. Then you need to judge whether your work is different from your competitors and how. And what are the unique selling points of your paper. Any good journal, reviewers will look for these three facts before even proceeding for review process. So normally what I ask my student, I ask them to define the structure. Sorry, the skeleton came before, the skeleton should have come now. Then only I start asking them to start putting the flesh into this skeleton. So they define the structure and start populating sections. Yeah, normally what I ask is, I ask them to send me the paper with the structure and some of the key messages in point form and tables and figures that they are going to include. Then you break down what the ideas that you need to convey into paragraphs, and make sure that you are writing to a particular audience. Right now, I have seen that in some fields, they never bother about the audience. They use the abbreviations, assuming that audience. Now, if I write in a paper SVC, there are many possibilities for that abbreviation if you won't define it. So remember, you are writing it for a particular audience. And it must meet these criteria before it is publishable. It should match to the scope of the journals. Remember, as I said, there are many journals available, so you can select the best journal which match to the scope of your work. The quality of the paper must be sufficiently high. It must present a novel results, and it must be significant enough to be worth reading. Now, just to take you through the review process, I am a editorial board member of a few journals. So this is the process normally any journal would go through. When set of authors submit a paper, the editor or the editor-in-chief will do what we call the pre-selection. He will check whether the paper has high plagiarism count. If you have plagiarized from others' work, your paper will be rejected straight away. Or check whether the paper is worth send it to the review process. Some papers are badly rewritten, the quality is so bad, then of course they will not send it to the reviewers. If it is good quality papers having novelty, then of course it will be assigned to reviewers. And the reviewers will go through the paper and they may straight away give the decision. Either they may say reject, or they will ask to revise and resubmit. Occasionally, the paper may select accept at the first instant, but I don't, in good journals, it's very rare. So when you ask to revise and resubmit, you kind of do the same process. You take the reviewer's comments, carefully go through them, and revise your paper based on the reviewer's comment. Then when you resubmit, it will be checked against the reviewer's comments, and if further revision is required, it will send it back to the reviewers. Now, one important message I wanted to give: after you receive the comments from the reviewers, you should very carefully address those comments. Never try to give answers to the reviewers' comments. I know that some people are writing paragraphs and paragraphs. You should always answer to the reviewer's question through the paper, and never challenge the reviewer. As I said, always address their comments through the paper. For example, this is a simple one which we recently did. You can see that our response is very short. This is the blue one is our response to the reviewer. Then we say that please look at the new sections we add. In page 2, section 1.2, we have added this, and you can see in our response, there are so many sections like that addressing reviewers' comment. Of course, whatever I am telling right now may be obsolete because we never know. Maybe very soon there could be journals. They will base whether the paper is good or bad using Facebook emicons, such as like, heart, and all these. So, if that is the case, of course, there's nothing much candid reviewers can do. Then the next thing, very important aspect you need to think about when you are doing research is your impact. Let me take you to two examples. There are two researchers, A and B. They are educational qualifications and the profiles are identical. So you can assume that one of the two best researchers in a country. Now, the Prof A applied for a research grant to work on a specific disease that reduces the milk production of cows by 10%. Prof B applied for a research grant to work on the psychological situation of cows when their babies are separated from them. Remember, in many farms, in order to get more milk, they take the baby cows away from the mother so that all the milk can be consumed, can be extracted. So the Prof B wanted to look at the psychological situation of the cows. Now, both this research grant application goes to a funding agency. Remember, any funding agency in the world will have limited funds. So, if you reflect on these two grant applications and see which one will be supported, of course, you will have your own opinions. If you look at in more humanitarian grounds, the Prof B's grant is important. So you may select to give funding for that. But remember, funding agencies are more look for value for money. So definitely the Prof A's application has a direct economic impact. So that impact makes the funding agency to support that. Prof B's one may be supported in a country like India, where cows are considered as sacred. So remember, the papers or any outputs are not adequate. When I say output, it's the papers, PhD students, MPhil students, and so on. You should have outcomes, which are the impacts, economic impacts, impacts on public policy and services, impacts on society, culture, and creativity, health impact, impact on practitioners and professional services, and impact on the environment. Now, for example, the example I used before, we developed this DC microgrid. We developed the microgrid controller, and we went into the funding agency and presented our works. They were not that happy. The reason was, I know that my MPhil student put a lot of effort to create this piece of equipment, but for funding agency, there was no impact there. So we were asked to do extra work. So we did some extra work. We look at where this controller, where this DC microgrid can be used. So we did a survey in many buildings, and we found that in banks, the load distribution is such that around 72% are air conditioners, around 15% are office appliances, around 10% are lights, and other appliances are only 9%. Remember, the banks operate during the daytime where the solar PV is available, and the modern air conditioners are inverter driven. So there is a DC bus where you can directly use DC, removing the AC to DC conversion stage. Your lighting is LED. So you don't need AC bus. Right now with the AC bus, you need AC to DC converter and a power factor correction. Your office appliances like computers, again, you have a power pack, convert it AC to DC, then you have the power factor correction unit. So if you use this DC microgrid in a bank, you can have 25% energy reduction. Remember, the banks, now the modern banks have used all the new energy efficient products. So there's no possibility of reducing the energy further, but this approach will give you a good economic impact. Then final point I wanted to give, always change your field. When I say always change your field, you may think that no, now this is the right time to change and think about medical research. No, don't do that. You have to be in your main research area, but the sub area can be shifted. For example, I have shown you how I related my work to the COVID epidemic, which is what I called change in research field. Let me take you through some changes happened during my life. I did my PhD on power electronic application to a power system called Advanced Static Quark Compensator, STATCOM. Then immediately after I finished my PhD, I had an opportunity to work with Siemens to install a 4 megawatt advanced static quark compensator in a wind farm in Denmark. This is the wind farm, head or whatever it is. I'm not good at pronouncing the name of that. So the Siemens build and install this advanced static quark compensator. Through that, I went into wind power a little bit. And then I was working on the controllers for wind power. If you look at my citation, you will see that there is a paper where we define the controllers for double-fed induction generators, which has almost hit 1,000 citations right now. So that is how I moved from hardcore power electronic man to a the wind power applications kind of person. Then, of course, look at grid integration of wind farms. Various ways wind farms can be connected. And more recently, worked on the multi-terminal HVDC. And then from wind, I move on to the more renewables and now into the smart grid and so on. And these are the smart grid research right now we are doing. We worked on many areas on the national grid, and we have developed some algorithms, we have developed some products, and we are also been developing some new products. For example, a frequency following smart transformer is one of our products which is ongoing. So right now we do a lot of research on this area. Okay, that's basically the end. I will pass the mic to Akila to continue with the Q&A session.
Thank you very much, sir. It was a very important session for all of us. And we had some questions. How can someone in industry, like non-academic, become a good researcher? Appreciate if you can share a few tips, especially for the telecommunication industry.
Okay. Now, the main difference between the research that we do and the appropriate research industry required, the industry research has been done somewhere else before by academics, and or industry keep their research as trade secrets and you are not allowed to publish. So your outputs and outcomes are sometimes hidden. So that's always a dilemma the industrialists are having compared to academics. But if you wanted to be a good researcher in industry setup, first you need to think of I mean, this is a bit hard in our industry in countries like Sri Lanka, but you need to look really towards the future by 5 years so more. Now, within the next 5 years, whatever the new work that you may think would have been published by researchers, so there's nothing much you can do. But if you think from 5 to 10 or 10 to 20 years ahead, then of course you can do a lot of work. But only thing is whether the industry is willing to fund that kind of an idea. For example, I know that right now, National Grid in the UK doing a lot of work on their decarbonized power industry, which is aiming at 2030. So they are looking at 10 years ahead. So if your industry is willing to fund a research program which is forward-looking, of course you can do good research. If not, it is not the research path you should go for. You should go for innovation path, where you don't bother about research publications, but you work on more patents. I think that would give some idea.
Okay, sir. Thank you very much. There's one question more. Like, as a researcher, would it be a must to maintain a research profile in ResearchGate or Google Scholar?
I mean, if you are living in 5 years ago, then of course, you know, nobody had I can't remember, I was having a Facebook account. I was not bothered to sell myself anywhere. Only I was selling myself through the known contacts. But today, if you look at the market is so competitive. So people are using various ways of selling yourself. So if you wanted to be a good researcher, it's the same story, because if you don't publish your profile and make it exposed to the community in this current market scenario, I wouldn't believe that you have a lot of. I mean, remember, it's basically the research means basically getting becoming a good researcher means getting good research students, getting research grants, and for all these, your profile matters. So the visibility of your profile to outside world is very important for all these things. But you know, with maybe after this COVID-19, people may think, you know, what you call it, think more in terms of Buddhism and think that, you know, no point of doing all that. You know, if that happens, of course, you can think of not publishing or not exploring your profile in various places.
Another question. For a review paper, is it only enough to summarize the papers? If not, what are special sections should it have?
Okay. As I said, review papers are very hard. Now, it's not summarizing papers. The most important thing is under which subtitles you must summarize papers. So now let me try to find an example. Let's say you wanted to review the papers on energy storage. So you will find papers related to the chemistry of energy storage, maybe, I don't know, physics related to energy storage. Then there are converters for energy storage. There are controllers for energy storage. There are many different applications for energy storage. So you can find, you know, endless different subtopics under energy storage. So a good review paper should focus on one particular area. For example, if I'm looking for energy storage for grid applications, then I must look for papers which tells the chemistry in terms of energy density and energy capacity. Then that could be one section. Then I need to look at papers where which can talk about the grid integration of energy storage. Then I need to look for papers which talks about grid support from energy storage. So you can kind of break your topic, focusing towards your main idea, and then look for many papers under each subtopic, and then summarize the papers. But remember, when you are summarizing the paper, always keep in your mind the overarching aim of your paper, which is, in this particular example I took, the overarching aim is what is the application of energy storage for grid. So that is the overarching idea. So even when I'm summarizing the chemistry, I must keep that in my mind. I hope that gives some idea.
Yes, sir. Next question. Can you give us some suggestions to improve awareness about global reference research problems that we can access and work on it to identify the domain of our interest?
Sorry, can you repeat the question?
Can you give some suggestions to improve awareness of global reference researchers problems that we can get access and work on it and identify the domain of interest, like new trends and all, how to find out those things?
Okay. Now, I would start other way around. I would start from my own interest. If, for example, I did communication theory, and I got A pass for communication theory, but I could remember the names like white noises and stuff, but I never wanted to work on communication because that was not my passion, which I realized, when I started as a undergraduate. So you would first look for the interest before you remember this is like the ocean. The research papers today are like an ocean. Now in the ocean, which area, which fish is kind of dominant will be very hard. But if you have an idea, this is the kind of fish I'm looking for, then it's easy to find areas where that fish is available. So you first, in your mind, you kind of start with a big research interest, area of research interest, then break down into sub area, and then look for, I would use, the search engines such as IEEE Explorer, Scopus, Engineering Village, or there's one more, Science Direct, and you type your keywords and look for the papers which are current in that area. You can always define the time frame in these search engines. Now, I'm sure all these search engines can be accessible, but you may not be able to access the papers. But you can get an idea about the current trends using those kind of search engines. Then once you have that, once you decide that this is the sub area I'm going to work on, then you can look for ways to download those papers and read more to understand what exact research areas are more dominant in your field of interest.
Okay, so there's one more question. Like when we are doing the research, sometimes we don't get the expected results if we try more harder and harder. But in such cases, how to be motivated and keep the interest as it is?
I mean, I think, like, according to my knowledge, the paper which is cited the highest number of times in Google Scholar is a paper by, in fact, one of my friends, Goran Prabha. The paper is basically telling they did some research and they failed, and basically paper tells that don't do this because the research is something that you will not always have the good results. You will you will have some research you will end up as you expected. Some research you may end up awfully bad. So if your research fails, look for points where the research fails, and if you can give a message to somebody not to do those things, then of course you can write a good paper, and I'm sure that kind of papers are welcomed by journals. But then you can I don't think you should go backward, because it's unlike you are not doing rocket science. Your research is in the areas of electrical and electronic engineering. I don't believe that you can use the same work but slightly different application and see how you can use the same results for the so that's kind of second application. So you should be able to always find that kind of area, and if you have an issue, you can talk to a experienced researcher. I'm sure he can pick areas that can stem out from your what if you wanted to call it a failed research, from your failed research, but it's definitely not a failed research.
Thank you very much, sir, for the motivation facts. We are at the end of this webinar organized by IEEE Power and Energy Society in collaboration with IEEE Young Professionals Sri Lanka and IEEE Women in Engineering Affinity Group of Sri Lanka. Yes, sir, on behalf of the organizers, I would like to extend our gratitude for conducting this session for us and dedicating your valuable time. Thank you for sharing your experience and insights on these aspects with us. We hope the information that you shared with us will be helpful as professionals and as students in power sector and any other area as well. Thank you again for your thought-provoking and well-presented session. Dear participants, we are thrilled by the attendance we had today, and thank you all who participated and helped to make this webinar a success. Hope you all keep in touch with the future webinars as well. At last but not least, we are facing a global pandemic, COVID-19 these days. Hope you all are safe, keep the distance and wash your hands properly. Have a good day. Thank you very much, sir.
Thank you, Akila. Thanks for organizing this event. Thank you.